So I'm just making this quick video on the Hyperboloid of Revolution within GeoGebra. So this is actually a follow-on video from the one where we made the physical model, because there's just a few things I want to kind of clear up and just to once again emphasize the visualization of this shape. So in the physical model, we had just two sponges on the top, and we had skewers going around the circumference of the circle. But we were talking about how all these elements are parallel to each other, but when we were twisting the physical model, not all of the elements were staying perfectly parallel. So this, and we couldn't see the throat circle in the middle. We couldn't see it. We could see it form, but we actually couldn't see a physical circle. So I just want to use a virtual representation and basically show you it through an animation. So just to start off, just another kind of principle. I have the elevation of my Hyperboloid of Revolution, well, just the line, and there's the axes and my two circles. But in elevation, this line CD is actually called an asymptote. And an asymptote to the curves are elements which are seen as true lengths in elevation. So we can see we're looking in the elevation here, and this line CD is actually a true length. So I think GeoGebra is actually a brilliant way to represent or to show the formation of a hyperbola of revolution. So yeah. So what I'm actually going to do now is I'm clicking point D and I'm clicking point C, and I want both of these to rotate around the two circles. And these two circles, as you can see, are the center points are B and A, which is our axes. So I have both of them selected. So I am going to turn on my animation. And if you see this blue line at point E, we can see the throat circle actually being formed. So I'm just going to let this animation finish. So this is our hyperbola of revolution. So you can see there's the throat circle. Line AB is our axis, which is here. And once again, here's our throat circle being formed. So this really does show the principle of how the lines are all parallel to each other, because as you can see, when the shape is forming, C is constantly staying the same distance away from point D down here. So I drew them, that was just a random line, and I fixed them to both circles and I rotated them around at the exact same distance, and that can just keep on rotating around those circles and the same shape will always be formed.